All right, guys, how are you? Good. I'll be quick. Dr. Rashida and Dr. Arman already took my time, so I think I have 2 minutes. Is that what it is? Thank you. There you go. So he just, told me this morning, please be on time. Only 10 minutes, but my time is already gone, right? That's fine. So, electrodynamics concentration. If you don't know what controls is, I'll be worried, about electrodynamics in a way because it's more complex because we're using a lot of physics, right? So electrodynamics, it's an interaction of electric currents with magnetic fields, right? So everything is pretty much, whatever we use here, like a laptop or a cellular phone or anything, if you open up, you got chips everywhere, transmission lines, power buttons, you just name it. Everything is electromagnetics in there. So I think it's very important. And then, especially you're using physics, right? I mean, physics is one of the areas that you need to master to be a good, electrodynamics guy, or semiconductor, or also there's a concentration on magnetics as well. So, but we actually merge that into electrodynamics. So I think it's pretty much covers everything. So the next, so why is important? I think I just picked 3 items in here, okay? Just be on top of technology, right? You have to. You have to start reading, right? It's very important. Start reading all this, magazines and technology. And then this will develop your technical skills along the way, right? So you have to develop those to be a good engineer, right? Especially in this area. And then you have to collaborate with society, right? Pretty much, IEEE transactions and, different outsources, pretty much in every area related to electrodynamics. So this is pretty much why I think it's important, and then we need to obtain and grasp all these tools that we're giving you in a way to be successful, right? If you succeed, we succeed as an institution. So I think it's very important for us to do that as well. And then students will be able to demonstrate, competency in developing, solutions, right? And be one of the leaders in your field, right? So if you like, electrodynamics in a way, you like physics, and you just try to work on things like they're not in the market, and you try to develop something new, innovative, do it, right? Society might need that in a way. So, and you will be one of the leaders in that area. So I think it's also, it's a plus, right? Job opportunities. Every semiconductor company will love to work with you, okay? You name it, anyone. We have physics background. We are in a way to develop new things, based on your background. Just do it, and they will just pretty much, hire you as an entry-level position, and then you have to demonstrate them that you have, abilities to do that. They will put you in different areas, as a product development engineer, process engineering, manufacturing, and then they will relocate you depending on your abilities. So you have to be, prepared for that. And then don't look for any babysitting stuff. No, you have to, you just try to understand your problem, and then you just, brainstorm that and see where you can go. Okay. But I think it's important for you to understand that, okay? Electromagnetics, interference, electromagnetics capability, it's important as well. There's a lot of stuff out there for you guys, especially on RF as well, on communications. I think, everything is interrelated in a way, so opportunities are there. So, and then power systems, whoever likes the transmission lines area, smart grid, waveguides, and all this stuff, I mean, it's available for you. So those are the companies that you might work for. I mean, like government, they're just dying for you, to go there and work on electromagnetic stuff, okay? They want to discover new things, metal detection, it's hot right now. I mean, if you know electromagnetics well and you know your physics well, I think you had good opportunities to work for them. The courses, based on my experience, I taught pretty much all these courses so far, and my research is in microelectronics, based on semiconductors. I worked for IBM for a couple years there. I started as a product development engineer and then moved to testing for a while in this cross-sectional area of the chips, for Qualcomm. Back then, when you got this flip-flop phones, back in like 10 minutes. Is it Dargan? Okay. All right. So those two, the transceiver and receivers, pretty much. So I worked for them, and it was such a quality experience for me to work with them. MEMS, microelectrical mechanical systems. I did a lot of thin film deposition on this, different frequencies for resonators and filters. Superconductors down in temperature, cryogenic temperature, 77 Kelvin, so we can have no resistance, and there will be a lot of applications, but it's kind of expensive. And then we just try to work on room temperature rather than just going down in temperature because it's money-wise. So. But we can do that on magnetic sensors, like I just mentioned EMI and EMC, and also data analysis for that, which is a new project coming up soon. So I'll tell you about that later. Okay. So and then I got these pictures here, like the microelectronics. It's just an IC of a motherboard, and the second one is it's a MEM. You see all different structures, like different layers. So there's a lot of metal depositions, and then you have different filters and resonators and different frequencies, and depending on the application that you're using. So pretty much that. So it was quick, 7 minutes. So any questions, guys? So 10, 60 seconds.